Hello again and welcome back. As usual, this is Becca going by Nightcat or Nightcat's Meow most places online, and I am here again to talk with you about Linden Scripting Language. So, last week I showed you how to read from a note card. The week before, gave you a primer on animation. This time we're going to put them together and show how to pull a series control a series of animations off of a note card. Next week, I will get into what I think this was ultimately for, which is a limited form of animation overrider, and we'll actually look into how that would actually work. But this is going to be a little bit simpler and a little bit easier to get going. As you see, I just threw a bunch of dances in there. They're just simple little partial dances here. We'll just go ahead and rename them all. In this case, I'm not really great with animations, so I don't really have a bunch of custom ones to toss to you all, and I might have tried to come up with something sort of basic and derpy for you, but I have not been having a great week. So we're going to start with line 1, dance 1, line 2, dance 2. Line 3, dance 1. Line 4, dance 3. Line 5, dance 2. And last line, dance 4. Why am I setting it up this way? Because this way you would have the option, if you had a series of animations, you could build different routines out of the different animations. So I can actually show you how to make something of use, driven by a note card. You could have different note cards that would have different routines. In fact, we're going to rename routine 1. Do not need to replicate those. We're going to make this one routine 2, and we're going to change routine 2. We're going to make routine 2 really, really simple. Just 1, 2, 3, and 4. Alright, so in order to make this whole thing work out, the first thing we're going to do is we're going to give this the ability to read one of our new cards. Right now it is only set to read test card. So we'll change it to routine 1. Save. Minimize that. Minimize that. Click it. Dance 1, 2, 1, 3, 2, 4. End of note card. Go home. All right. So that's still doing everything that it did before. So the first thing we're going to add is the ability to read. Hold on. Apologies for the rough cut there, but that is a call I had to take. Alright, so we've gone ahead and changed it to show that note card. We want to set it up to be able to choose which note card you want to have it read. So a way to do that is to set up a list and have that list feed in for you to choose. I'm going to go ahead and add the listen in here because that's going to be important in a minute. Alright, so first thing is we're going to create a listen for this that we only need to have active when we are in fact going to be working with the menu. So we need to create integer ears, as in put your ears on, as in listen. Ears equals listen. That'll be, we'll say, channel 22. Just picking a channel. Don't care what the object is named. We want to listen for the owner. And we want to be able to listen for any phrase we want. Next, we're going to assemble a list. List. Cards. equals, that is just a blank, empty list. Now, what we need to do is we need to have it automatically determine how many items of a given type, in this case note cards, are in the object so that you can dynamically add them. Give inventory, let's get inventory. There it is, get inventory number. That's, I believe, what I am looking for. Returns an integer that is the number of items of a given type in the prim's inventory. That is exactly what we need. And what type? We're looking for note cards. Integer is type. We want, there it is. It's handles as inventory note card. Technically that means it is equal to the number 7. We could put the number 7 in, but it is much easier to read the script later if we use the inventory note card like so. So now this integer count will tell us how many there are. Let's go ahead and make sure we see what's going on in this script. Integer debug equals true. One of my favorite little tricks. If debug owner say string, so we recast the integer into a string, count plus note cards detected. Then, because we're going to use a for operation to get things, we're going to say count equals count minus 1. That would give us the way it would be registered as is in terms of scanning the object. So that would make, if you had 2 note cards, it would read as 0 and 1 instead of 1 and 2. But there's another way we can do that. Integer I for I equals 0. I is less than, because less than means it has to be at most 1 less than the target number. So since we have 2 note cards, count is going to be 2. So we could take it down by 1, at which point we're using the numbers the same way the computer is, and we would say less than or equal to. But we can make this simple for people and just say less than. Then I equals I plus 1. So we want to say cards equals cards plus. Now, since it starts out here as empty, we don't have to worry about any other data. We're refreshing the list right here. So cards equals cards plus. Also, since the list is created here, it'll be fresh every time that you click to touch to click the object. So cards equals cards plus get inventory name, and we're going to double check exactly how the syntax on that goes, even though I remember the command is the right command. It's type and then number. That's what I thought, but I wanted to be sure. So inventory note card, comma, I. So what this line does is this for operation. We've done a few of these in other tutorials before. You have your starter integer, I, which is just a counter. It will keep counting until it is, and that is done wrong. We have 2 note cards in here, but that is done wrong. Less than or less than count. Count is where we dynamically determined up here how many note cards there are. So as long as I is less than count, and when this thing is done, it will raise I by 1. So the first time I is 0, the second time I is 1, the third time I is 2, the fourth time I is 3, so on and so forth, until it has run out of note cards. And then cards, the list we made here, lists always are contained in those brackets, equals cards, so the list you have, plus get inventory name, note card. Now the next part is we're going to create a dialog menu. This has got a few different moving parts in it, so this is why I want to bring this one up first. Come on, pop over. Thing's making me wait for it. There we go. Control C. Dialog. Key, avatar. This is who is going to get the dialog prompt. You can set this to register whoever clicks it will get the dialog prompt. You can set this to send to a specific person. Yeah, I was planning to build this as a HUD, so I set it for get owner. But you could easily go through and instead of setting it to get owner, you could say key who equals detected key 0. And then replace every one of these get owners with who. You wouldn't want to do this with the owner say, but you could replace all of those with who after you establish who is detected key 0. So the first key that's detected, that would be the person who clicked it. But for simplicity's sake, we're going to stick with get owner for now, but that would be how you change that over. We are also going to comment those out since we're not using them right now. String message. It's a string, so it needs quotation marks. Select routine. List buttons. These are going to be the options you have on your drop-down menu. Cards. That is the list we established up here. And then integer channel. We established the listen ears on 22. There you go. So the next thing we'll do is we're going to pop these right down here where I'm actually going to be working with changing them. And we're going to test this chunk of code. We already have an error. Ah, that's because I didn't change that. There we go. All right, the rest reads just fine. There we go. The owner say told us, the feedback told us 2 note cards detected, and we get the options routine 1, routine 2. So that part works just fine. So we're going to go down to the listen. If debug, owner say. Actually, you know what? You don't even need a debug on that. That's something that's okay to leave in normally. Message, because that'll be what is being heard. I'm going to show you how this works. Routine 2 has been selected. Now you see here, the first part of that before has been selected is just message. The message right here. That's the secret of these drop-down menus you see sometimes. When you use them, whatever option you click is the equivalent of your avatar saying it. So we will then note card query ID, get note card line, message. Since line up here starts at 0, this will automatically read forth the first line of the routine you select. We're not going to increment up the lines on that, not anymore. So there you go. It read the first line the same way it did before. But here's where we're going to start to change things. All right, we're going to start animation, dance. The reason why we're making a global variable dance that is equal to data, you're going to see in just one moment, because we're going to add something up here. If bad typing message equals stop animation dance set timer event 0 return. All right, what this just did is if you give the command, the only one we're pre-programming up here, stop, it will stop whichever animation it is told to be doing. It will set the timer to 0, so this will not trigger anymore. This will stop happening because it can't count to 0 from 0. And then return, it will exit out, because if we didn't exit out with a return, it would then proceed to run this code, which this could not actually work because there will not be a routine in there called stop. Or at least it would be a bad idea to have one in there called stop. So that should automatically loop the routine. So end of routine, go home, stop animation dance set timer event 0. All right. Give it permission, yes. We're going to start routine 1. There we go. There it is. Now it's changing animations. Changing animations again. End of routine. Go home. But it didn't stop. So, for some reason, it did not stop the animation. But you see how it can pull from a note card. It can trigger your animations. The only thing that I've got wrong is it not actually properly stopping the animation. So I can figure out why that doesn't work. And avatar health, stop animations. I can figure out what's wrong with that and work on the next couple of parts of this for next week's video. So thank you all for sitting through this longer than normal video. I wish you all good day, good week, good luck, happy coding, meow.